Section 3.2 is called complex numbers. Warren, take your headphones out, please. Thank you. All right, let's see. I would like to start out by just warming up some algebraic skills, some algebraic arithmetic. When we have a number outside of a parenthesis with more than one term in it, what do you guys need to do? Distribute. So we're going to distribute that 4, and we're going to distribute these 6. I'm going to get 4x minus 4 plus 6x plus 6. And then when it's all addition and subtraction, we look for like terms. And like terms have the same exponents. I'm sorry, not exponents. Variables to the same exponents. Yes, dear. Yes, it totally would be. Thank you. There was a 3 there the whole time. Just kidding. All right, so 4x and 6x, we're going to add those together because they are like terms. So we will get 10x. And then we're going to add together the minus 4 and the plus 36, which would be plus 32. Can I add together 10x and 32? No, because one has an x, the other one does not. This is as far as we can go. So question 2, I'm going to distribute the 7. 7y plus 8. What would I be distributing in the second parenthesis? What's sitting right here? A 1. So what happens if I take 1 times 2 or 1 times 3y? Yeah, nothing happens really. It's just the same thing. But just to be consistent, we could have distributed a 1. Yes, Emma? Oh my gosh, I don't know. See, what I'm doing right now is I'm making sure you guys are paying attention. And so far, we have 2 gold stars. See, when I talk, sometimes it doesn't. Okay, now we're going to look for like terms. So 7y is like term with 3y. When I add those together, I get 10 y's. Then I've got 56 plus 2 more, so 58. I cannot add those together because they are not like terms. All right, number 3, we've got multiple parentheses. We have to do what's inside first. So the first thing that we're going to do is distribute this inside 3 into the parentheses that it's outside of. That's my first step. So I have 3 bracket x plus 3x plus 6. So that gets rid of the inside parenthesis. And then from there, inside of the brackets, can I do anything? Inside of the brackets, can I do anything? Yeah, I can combine together by addition 1x plus 3 more x's. So I have 3 bracket 4x's plus 6. And bracket is the same thing as a parenthesis. So now I'm going to distribute my 3 into that bracket. And I'm going to get 12x plus 18. I cannot add those together because they are not like terms. That'll be as far as I can go. All right, on this next one, I need to move this. It's taking up too much space. Yep. Yeah. Okay. On this next one, what will I be distributing? Can't hear you. I will be distributing a negative 4, right? So minus sign is the same thing as adding a negative. So we're actually distributing a negative 4 in. So I'll have negative 4 outside of a bracket, x, And then when I distribute that negative 4, I get minus 16. When I distribute the negative 4, I get minus 4x. I have like terms with x and minus 4x. So now I have a negative 4 outside of the bracket. I've got a negative 3x, and I have a minus 16. Did I do anything wrong? Did I do it right? Got to second guess myself a few times today. All right, and then we're going to distribute the minus 4, and I'm going to get positive 12x plus 48. Can I add these together? No, because one has an x, the other one does not. Yes, Amar. Oh, it is 64, yeah. 3 times 16 is 48. It's like when we had 2 days from home, I lost all of my super math powers. I left them at home with my camera. Okay. We don't need to go through these. We're not going to hit any of that up today. All right. Now, here's my question in this big empty area. Here's my question for today. You ready for this? What is the square root of negative 4? Do we need to type it in our calculator? Should we type it in our calculator? I don't have a camera. I can't put my calculator up here. Sure, type in your calculator. What is the square root of negative 4? I wonder what the internet would tell us. I could look that up too. It does say error, but it tells you what specific error. It says error, then it says something. Oh, you're reading the very bottom. What's it say right next to error, right at the top? It says non-real answer. Okay, it says non-real answer. And we talked about that last time. We can't take the square root of a negative number because it's not a real number. But there are for real jobs that square root of negative numbers are dependent on. Did you know that to make electricity come through that plug on the wall, we have to use absolute value negative numbers? Did you know that? So because we have to use that to make electricity work, they made something up. They said, it's not a real number, so we're going to say it's an imaginary number. It's not a real number, so we're going to call it imaginary. That makes sense. But we need it to do calculations to make electricity, and electricity is pretty important, so we need these imaginary numbers. So what happens is when we have the square root of a negative number, what you're going to do first is you're going to use a property from Algebra 1 that allows you to take square roots and separate them by factoring them, unmultiplying them. So I'm going to unmultiply the negative 1 from the 4. And when I unmultiply that negative 1 from the 4, now I can find the square root of 4. What's the square root of 4? 2. Now here's what you're learning new today. And it's right down here. The square root of negative 1 is lowercase cursive I. I stands for imaginary. It's an imaginary number. The square root of -1 is I. So right back up here where I'm taking the square root of 4 and taking the square root of -1, I will have 2 multiplied by I. This is the square root of -4. 2I. So now we can take square roots of negative numbers. Yay! That's what we're doing today. Yay! Okay. So if r is a positive real number, then the square root of -r is I square root r. Here's an example. Square root of -3, we would separate to be square root of -1 times square root of 3. And then the square root 3 will stay square root 3. The square root of -1 becomes I. And if we take I multiplied by I, which is I squared, this is the second part here. If we take I multiplied by I, which is I squared, that is the answer, -1. So the square root of -1 is I squared is -1. Anybody know what I to the third is? Using the information I just gave you? So I squared is -1. So what would I to the third be? Genero. Eyes up. What's I squared, guys? -1. And then you just bring the I over. So -I is what I to the third power is. Maybe somebody can get this next one. What's I to the fourth? Jaden, you got a guess? Okay. You just weren't writing anything, so I figured you knew it already. Emma, do you have a guess? Oh, okay. So to get I to the fourth, we would do I times I times I times I, right? Okay. Do you know the answer to, like, if I combine any of those I's? Do you know the answer to combining any of those I's up there? Like, I don't know, if I combine two of them, what would you get if I combined I squared? Say it again. So I to the fourth is I times I times I times I. If I divided that I to the fourth into two groups and I made it I squared times I squared, that's still I to the fourth. Okay? Can anybody tell me what I squared equals? Can anybody tell me louder what I squared equals? Okay, so if I'm doing I squared times I squared, that's -1 times -1. So what's I to the fourth equal? 1. Yeah. I think sometimes there's like questions like that on the ACT. So if you're studying for your ACT, anybody taking the ACT soon? Yeah. Sometimes they'll have questions like I to a certain power on there. So, all right, let's move on. Find the square root of the number. The first one is square root -25. So you see that negative sign? Factor it out first. Let's do square root of -1 and square root of 25. Aya, what's the square root of 25? Oh, you're telling me the whole answer? Yeah, 5. And then the square root of -1 is I. So my answer is 5I. Okay, question B. I'm going to separate the square root of -1 from the square root of 72. Is 72 a perfect square? It is not. So I'm going to separate the 72 further. So now I'm going to go up here. I don't really have a lot of space. Actually, I should just zoom in, then I'll have more space. I always forget to do that. So if I have the square root of -1 multiplied by, I'm going to take 72 and divide that up into 2 smaller square roots. Can you guys tell me a perfect square that goes into 72? 9? Okay, so 9 goes in 8 times. Notice I'm not writing it over here. Because do you see how 8 still can be broken down further? So there's actually a bigger number than 9 that goes into 72. I'm going to get the biggest square root so I don't have to do a bunch of steps. 36 is the biggest one, yeah. I mean, I could do more steps. I just didn't want to. So 72 is 36 times 2, and then times -1 gives me -72. Now we're going to simplify each of these. Square root of -1 is I. Square root of 36 is 6. Square root of 2, I can't break down any further. The order of this answer is number, then the I, then the square root at the end. That's the order you write them. Number, I, square root. Okay, next question is -5 square root -9. Does anybody know what operation is between -5 and square root? What operation that is? There's nothing written there. Sierra, do you know what it is? There's nothing written. Things are next to each other with no signs. Do you know what that means? It's multiplication, yes. So we've got -5. We're going to multiply that by, I'm going to break down -9 to be square root of -1 and square root of 9. So I've got -5 multiplied by I multiplied by 3. Well, I am allowed to multiply together -5 and 3. So -15I. What does this say? This means you try for a moment. Go for it. Try it. There's 4 of them. Try them. I don't know how to pause my video here. gosh, where were you? Should have asked me a long time ago. Oh, wait that long. Ask me right away. Okay, so when you break up 12, one of those numbers has to be perfect square. 6 and 2 aren't. So what goes to the 12 goes perfect square? Multiplication goal. So we've got 1 and 12 doesn't work. 6 and 2 doesn't work. 3 times 3 is 9. Any questions? Did you get it? No. Yes, -1 and 4. You check your answers with mine? Yeah. Okay. Okay, what is the square root of 4? Did it on a different page already. Square root of 4. Did not write it down. The square root of 4. You checked your answers? I was asking Ryan. Yes, Ryan? Okay, when you're done, check your answers, David. Are we doing these? You check your answers. Check your answers. Anybody have questions? You see, every single one of these, I pulled the negative out. Any help on this one? Trying to think what's going in a 54. So if you guys, when you're trying to break down the square roots, if you're trying to break down square roots, if you don't have your like third grade multiplication numbers memorized anymore, it might be helpful to just have like a list of square roots nearby. I mean, not square roots, but perfect squares. What is 2 times 2? 4. What's 3 times 3? 9. 4 times 4. 16. 5 times 5. 25. 6 times 6. 36. 7 times 7. My third grader can answer these questions. Answer them with me. What's 8 times 8? 64. What's 9 times 9? 81. I'm going to move this. What's 10 times 10? 100. Okay, and there's more than that. But when you're trying to figure out like what goes into 54, you shouldn't be just randomly dividing stuff. You should be looking at these numbers. Does 4 go into 54? It doesn't. Does 9 go into 54? Oh yeah, 9 times 6. So really shouldn't take you an overly like long amount of time to find these. You just start checking perfect squares from a list that you either write on your paper or you already have in your head because you should have used it a lot in previous math courses. All right, the next section that we're looking at is talking about what a complex number is. So a complex number we write in standard form A plus BI. A is the real part. BI is the imaginary part. A is the real part, BI is the imaginary part. There's a little diagram off to the side over here that talks about all the numbers that you would ever have, ever in math, ever. There's no more other than this. You've got real numbers and you've got imaginary numbers. Those are all the numbers that you'll ever have in math, ever. And then inside imaginary numbers, you can have pure imaginary numbers that are just like 4i or 6i that don't have a real component piece to them. But not very often that I talk about just pure imaginary numbers. I usually talk about real or imaginary in my classes. Okay, equality of two complex numbers. This is not difficult. Look for what has an I in it. Let's circle what has an I in it. Negative 7i. Is there anything else here that has an I? Yes? What is it, Amar? Yi. Okay, I'm going to take a different color because I got colors. Why not? I'm going to put a box around what doesn't have an I. 2x does not have an I. 10 does not have an I. I'm going to make two categories. I'm going to have real, and in parentheses, I'm going to put no I. And then I'm going to have a category, imaginary. And in parentheses, I. Now there's this crazy funny symbol. I'm sure you've never seen it before, right? Right? In between these two sides. What does that crazy symbol mean? What is that crazy symbol? Come on, I'm asking silly questions here. Equal. It means they're equal to each other. So if they're equal to each other, the real stuff, 2x, has to be equal to the real stuff on the other side, 10. The imaginary stuff, negative 7i, has to be equal to the imaginary stuff, yi, on the other side. This has to be true for these two complex numbers to be equal to each other. Guess what we're going to do? No guesses? Nina, you guess what I'm going to do with that 2x equals 10? Just guess. I'm going to solve for x, yes. I'm going to divide by 2 and solve for x. I'm going to find out that x equals 5. And negative 7i equals yi. Jacob, guess what I'm going to do over here? Why am I doing that? Okay, you kind of trailed off there. I couldn't hear the last thing you said. You are correct. I'm going to divide by I, but what I want to get y by itself. I don't really care about getting negative 7 by itself. It does end up separating because I'm dividing it, but I'm trying to isolate the letter y, the variable y, so I can find what y equals. So in this equation, I am just finding the values of x and y that satisfy this equation, that make it true. Look, it says student practice. You try. You try it. You try it. You try. So for each of these, as you get them done and you check your answers, for each of these, I circled my real stuff, or I circled my imaginary stuff, I boxed in the real stuff, and I made them into 2 separate questions. From there, I just solved each separate question using Algebra 1. You really only had to use division. One that might have been confusing would be for question 6, knowing what to divide by. So you got to find that y. You got to find that y value and say, I need for y to be by its, that was way too big. I need for y to be by itself. I need y to be by itself, so we need to divide by the 4 and divide by the I so that we can get y by itself. So if you find the variable, divide by the stuff next to the variable. Is I a variable? Is I a variable? It's a letter. Is it a variable? Or does I have a numerical value? Emma, you look confused. Okay, you're not. Okay. I is not a variable. Amar, do you have a question? What? 4.5? 4.5? Okay, it's the same thing. Now, is that because you used your calculator? You just did it automatically? Okay. So I'm not going to do that. Like if we have to type it in Canvas, going to do that. I'll leave it as a fraction. Okay. Okay. So I is not a variable. I is equal to the square root of -1. It is not a variable. It's just a letter that equals some number that we can't really have because it's not real number. Oops. Okay. Okay, so when we have complex numbers, we can treat complex numbers a lot like we would treat variables. Just like we would treat anything that we're adding in math, it has to be a like term to be able to add it together. So for adding a plus bi and adding c plus di, I can only add together the real parts with the real parts, or the imaginary parts with the imaginary parts. See here, we're adding the B and the D, and we're adding the A and the C. We're only adding the real parts together, and we're adding the imaginary parts together, but you can't combine different kinds of terms. They're not like terms otherwise. So this is the same rules throughout all of math. In order to add, they have to be like terms. So for this one here, if I'm adding 8 minus I, and I'm adding that to 5 plus 4i, then I'm going to add together the 5 with the 8. And I'm going to add together the 4i and the minus I. And I'm going to put my answer, it says in standard form. I'm going to put my answer in standard form, which is A plus bi. So I have my answer correct in standard form. 13 plus 3i. This next one has a minus sign. So that means I have to minus the 3 and I have to minus the -6i. So I have 7 minus 6i. I have to minus the 3 and I have to minus the -6i. Which is the same thing as adding 6i, or 6i. Yeah, I forgot my I. Ryan, you okay there? You're just overwhelmed with how fun this is? I thought so. So Ryan, what's -6i plus 6i? Nope, try it again. What's -6i plus 6i? What is it? 0. So I'm not going to write it. My answer is just 4. I could also write it as 4 plus 0i. But since there's no imaginary component, I don't really need to write it this way. It's just 4. Okay, for this one, we're going to distribute this minus sign. Going to have 13 minus 2 minus 7i plus 5i. We will combine our imaginary parts and our real parts. So I will have 11 minus 2i. If you all have questions, you want to stop me as I'm doing it, don't be confused here for 10 minutes and then ask me at the end. Ask me as I'm doing it so I can answer your questions. Multiply. Write your answers in standard form, which is a plus bi. So we're going to multiply. First one, distributive property. We're going to multiply them. When you multiply stuff in math, question? A plus bi, the real plus the imaginary. There you go. Real plus imaginary. So we just don't want to write it as the imaginary plus the real. Do the real plus the imaginary. Okay, so I'm going to distribute 4i, which is multiplication. You're allowed to multiply things that are not like terms. So I can multiply 4 times I times -6, and I get -24i. Multiply 4i times I, and I get 4i to the second power. So this currently is not in standard form because I don't have a real number plus an imaginary number. I have -24i. That is my imaginary number. This is the imaginary number. What is 4i squared? So what does I squared equal? Was that Amar who said -4? Was that you? Oh, that was Jaden. I'm sorry. I have no idea where the noise is coming from. Jaden, how'd you get -4? Correct. I to the second power is -1. So when I have 4i squared, what I really have here is plus 4 times -1, which is -4. So my answer for this question is my real number is -4, and then minus my imaginary number, or plus my imaginary number, -24i. So we have our real component, -4, and our imaginary part, -24i. Question B. We're multiplying 2 terms by 2 terms. I mean, we've done a bunch of that lately. You can do that by using that FOIL method, or you can do it using the box. It's up to you. I feel like doing the box this time, but it's totally up to you which one you want to use. I would have 9 minus 2i and -4 plus 7i. So in my first rectangle, I would have 9 times -4, -36. Then this rectangle over here, I'd have -2i times -4, so positive 8i. Down in this rectangle, 7i times 9 is 63i. And then in the last one, I'd have -14 I to the second power. So we'll combine like terms, and my middle is going to combine. So we get a -36 plus 71 . I, and then minus 14I squared. This has to be written in standard form that has a real number plus an imaginary number. So this minus 14I squared can't be there. So we take I squared and we say, well, that's the same thing as negative 1. So minus 14 times negative 1 is positive 14. So I can add that to negative 36. Negative 22 plus 71I. So everything we're doing today is stuff that you should already know from other classes, with the exception of, not classes, other math classes, with the exception of I squared is negative 1. That's kind of the new thing. Or square root of negative 1 is I. Okay, these next ones are just kind of similar to what we just did. I'm going to cut it a little short. I'm not going to go through every single one of these. Maybe like 2 of them. How would we multiply negative 3I and 10I? How many terms is negative 3I? How many terms? Yell it out. How many terms? Terms are separated by plus and minus signs. So how many terms do we have here? Nobody knows? 1. Thank you for yelling that out with your finger. 1 term. How many terms we got sitting here? 1 term. There's no distributing. It's literally just multiply the stuff together. Negative 30, I to the second. Is that my final answer? No. Negative 30 times negative 1, which is positive 30, is my final answer. This one, I distribute the I. 8I minus I squared, which is negative 1. Which is positive 1. Is that my final answer? 8I plus 1, is that it? Trying to trick you, is that it? No? Ariana, why? Put it in standard form. 1 plus 8I, yes. Oop, this one's missing a parenthesis. This one I'll do by FOIL method. I did the other one with the box method. I'll do this one with FOIL method. So I'll do 15 minus 3I, 5I, minus I squared. Combine like terms, and I get 15 plus 2I. What is minus I squared? Minus negative 1, just plus 1. Plus 1, so my answer is 16 plus 2I. All right, the last little bit of this, solve quadratic equations. So this is what you were doing the past day or so, 2 days, day or so, solving quadratic equations. If I have x squared plus 4 equals 0, I can solve this by factoring, graphing, or square roots. You have to start analyzing this and decide what you think would be the easiest to solve this by. How many people prefer graphing as their number 1 choice? Me neither. How many people prefer factoring? Okay, we can try factoring. So factoring, we're going to look at well, first of all, it has to say equals 0, which it does. So we're going to look at this. There's two terms. Is there a greatest common factor? GCF? There's not a GCF. So when we have two terms, we look for subtraction. Is it subtraction? We can't factor it. It's not subtraction. We can't factor it. So back to the drawing board. Can we do square roots for this one? Can I get a perfect square by itself? Subtract 4. And then I square root both sides. Oh, but who listened? What do I have to do when I square root both sides? I don't know who's talking. It's a girl. Sophie. Oh, before that. There's something I need to do before I even look at what's underneath the square root. You had to watch your notes. It was in the notes. When I put the square root symbol in, I got to do something else. I even mentioned in the notes. I made a mention to my geometry class last year. I guess it depends which notes you watch, Sophie. I haven't said something about my geometry class. See, this is what can't happen. We can't go remote and you not do your work. This can't happen. We'll have a quick talk about that after I'm done with this video. Square root, you have to put a plus minus in front of it. There are two answers that are possible. My thing turned off. You have to put a plus minus. When you put the square root in, you have to put a plus minus with it too, or you will not get the correct answers. You'll get like one of the correct answers. You won't get both of them. So when I do that, I will have x equals, now I'm going to look at plus minus square root negative 4. Now I'm going to look at separating that negative from the 4. So I'll have plus minus square root negative 1 square root 4. So I'm going to have plus minus 2i. So there are two answers, 2i and negative 2i. On Canvas, when you go to type these in, you're going to put the negative number first, or you're going to miss a bunch of questions. And I wrote that on every single question, like every single one says, put them in order, put them in order, put them in order. So I want you to make sure you put them in order so you don't miss them all just because you're putting them in the wrong order. All right, this next one, let's try the same thing. Let's add 11. I'm going to divide by 2. And then I'm going to square root. But as soon as I'm putting that square root symbol in, I have to put a plus minus in. There will be two answers. As soon as I put that square root in, I have to put a plus minus. I will have x equals plus minus square root negative 18. Just not done yet. I'm going to break this down. So we have plus minus. We have square root negative 1, square root 9, and square root 2. I broke down the 18 to 9 and 2 as well. So I'll have plus minus 3i square root 2. All right, and then the last example says find the zeros. Who watched their video? What does it mean to find the zeros? Ari, what's it mean to find the zeros? Graphically, it means the x-intercepts. But for this equation, what do I do? Because I'm not going to graph it. If I did, then I would find the x-intercepts. What does it mean to do to find the zeros? So finding the zeros means to find when the function is equal to 0, which on the graph it would be the x-intercepts, because the y value would be 0, or the f of x. So all you have to do for this is write 0 equals 4x squared plus 20. Oops, that's a 12. 20. So I'm going to solve this. I'm going to take away 20 from both sides. Divide by 4. And I'm going to square root. What do I need to do when I put in a square root symbol? What do I need to do? I need to hear you say it. I need to hear everybody say it. What do I have to put when I put in a plus minus? I got to put, sorry, I said the answer. What do I have to put when I put in a square root? I need to put in a plus minus, or you're going to get half of your answers wrong. There's 2 of them. So now I'm going to have x equals plus minus square root negative 5. I'm going to break that down to plus minus square root negative 1 square root 5. So I get plus minus I square root 5 as my 2 answers. And then these are all like just more review. I'm not going to review. I'm going to just end the video here. If you would like me to try one, if you're like looking down below and you're like, ooh, I don't even know how I would start that question, I could definitely go over it. I'm going to end the video though. Oops.